That makes sense.
I'll give you the sense of careful with which this smells like every time for you. That's why I'm giving it. So you're running every for each array.
We need to test this. We're not equal. I want the information. Yeah, because like that's not well, it's not more. It's a right? It's rated with the raised. So if we create conditionals where I is equal to here, and if it finds that yeah. Yes, there's a message for that. Everything's good. Yes. No. Let's see. Everything is crashed landed on my brain just now. And it's like, oh, we don't have to do anything else. Just, and use the method. So remember, all it's going to do is return true. And if it returns true, the reason we don't need time. It's already existing. Wait, but do you want to get rid of it? Sorry, I need this. We just like everything just kind of crash landed in the brain. I want to make sure that I'm in the right place. We didn't need to do this. We just have to use every because iterating implies this group. We need roughly.
It's okay to do it that way.
Yeah. Everything just kind of went. I was like,
All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. So, by the way, unfortunately, I forgot to start recording earlier, but now I am recording. I'm really sorry about that. But I could probably, if we end up needing it, I'll go back and just record myself talking through the beginning of the game. Okay. How did we do on this one? Yeah, okay. Yeah, it's tough. I know, this is a tough day. This is our first, like, big object-oriented building something, like, real game. Okay, so it said taking a board, but default to is this board. So what do I need to add? What's the first thing I need to do? Board. Okay, so I'll explain why I'm doing, why I do that in about 5 minutes. But for now, let's just leave that at that. Okay, and then we don't need this anymore because that was just that direction. Okay, so now it says return the symbol of the winner. If there is one, else return undefined. So, do I have a method that would iterate through the board and give me it by rows? What's that method? For each, right? If I do board dot for each, I end up with a row, yes? Okay. So, do I have a method that I can call on a row that tells me if every element is the same as something? Every, right? This was similar to one of our problems in the past. So I can say if row dot every, which will be element, is equal to row at the 0th index, I'm going to go ahead and update our winner and just say this dot winner is equal to row, or I can just do element. Oh no, I'll do row at 0. And I said I want to return the symbol. I think this will actually just be enough, just to update the row. Update the winner, right? If I end up having a row, that's perfect. Our winner will be updated. Otherwise, it will not. I can go ahead if I really want to. I can return this dot winner just so we can more easily check. And let's test this. So we're going to go to our board. Okay. And we can place a mark. And let's say we place a mark on, so we have 4, 5, and 6, right? So this would give us a row. Then I'm going to call board dot is horizontal. And when we run this, we'll get an error. Because L is not defined. Oh, thanks. Yeah, floppy, yeah? L. Whoops. Better. Try again. And we see that X is what came back that time. If I didn't have a winner, so let me just comment on one of these, and run is horizontal, we should see undefined, because our winner is still undefined. Okay, so we're able to successfully update our winner. Questions on how our horizontal is working? Yeah, Brandon. Sure. So we've got our board. It's a matrix. Every element in our board is one row. So we're saying for each row, we're going to look at that row. This row is an array. We say every, so is every element in this row equal to the very first element in this row. If they are, we know they must all be the same thing. And if that's the case, we're going to update our winner to be the very first element in that row, because that will be the winning symbol. Okay, so sure, these are just tests. Right, we're just placing marks and then testing. Okay, so next method, yeah? So this is going to be kind of a fun thing to think about. So this is what our matrix looks like, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I transpose this, it would look like 1, 4, 7, 2, 5, 8, 3, 6, 9, right? These are all, it's as if I took it and I made all of the columns become rows and all of the rows became columns, yeah? This is called transposing. So I'm not going to make you write this one. Cold, I'm going to help. And we'll see what I'm talking about in a second. So I'm going to go ahead and write a helper method. Because the overarching idea is if I transpose this matrix and I do that, then I can just reuse my is horizontal, which is relatively easy to write compared to writing one that's going to check like that. It's easier to write it to check like this. And so if I transpose it, I can do that. Does that seem like fair? All right. So I previously wrote this. First thing I want to share is how I wrote it in REPL, so we can visually see it. I know. Yeah, this one's for Patrick. Let me shrink this down and pull this. Okay, so a little bit with how this essentially works. We have this board, 1, 2, 3, 4, 5, 6, 7, 8, 9. I create a fake, just like an empty array. I'm going to iterate through this board. I don't care about the element, I only care about the I. I then assign the I a new index at I in duplicate, and I set that equal to an empty array. So that way, there's going to be an empty array in every spot. Then, I'm doing another loop through this row. I'll call this row. Then I'm iterating through the row, and I don't care about the element. I just care about the j, and I'm saying dupe at ij is equal to board at ji. So that's going to flip things. Yeah. Yeah. And so, what? I think that's like, let's see. There you go, no problem. So this ends up giving us back this nice array of 1, 4, 7, 2, 5, 8, 3, 6, 9. Okay, this is how that's written. I'm going to go ahead and go back to my code. And we can write it over here. I've already written this, so I'm just going to copy it, and I will Slack it as well so that we can use it. Oh God, computer's like all over the place. So this is going to look like this, and I'll go to Slack and send it. Okay, so that's That's the transpose function here. It creates this duplicate. It's going to go through each row. It's going to set a new, at I, it's going to create an empty array. It's going to iterate through the row of the board. And at j, it's going to swap this board ji, and it's going to return our do. So how can we use this? It might be the next question. So we're going to use this for is vertical. So for is vertical, we're going to say is vertical. And I'm going to say let transpose equal this dot transpose. So this is going to go ahead and give me that transpose matrix. And from there, I'm going to call this dot horizontal. I'm going to pass in our transpose. Right, this will still update the winner with the appropriate symbol. And let's try it out. So we'll go here and we'll place our mark on 1, 4, and 7, yeah? We'll run is vertical. Well, I guess I can just, actually I'll just return this. So that way we can actually see it. And we're expecting to see X. And we do. And if I didn't have one there, we'd expect to see undefined, which we do. Questions on that? Yeah, Isaiah. Yeah. So our is vertical function is just going to take, it's going to make a duplicate array, like a matrix, that's going to already be transposed. Then we're just going to call is horizontal on that new matrix. Yeah. Board is equal to this board. So I don't actually, oh, good question. So I think what you're asking is if I want to use this board and transpose and like do assignment changes. So I definitely don't want to do that because I just want to check the vertical. I don't actually want to change the game state of the board. That's why I'm making a duplicate. Because if all of a sudden, if we were playing with the board and all of a sudden the board got flipped to this, the user would go, what the hell's going on here? Right? They'd freak out. Then, or we'd have to transpose it back. This way our board never actually changes in the way it's set up. Okay. So we got one more method array, yeah? All right, this one's all you. I want you to write is diagonal. Again, this should update winner to symbol if there is one. All right, so give that a shot. Oh, push all the code I've written.
top to top, or bottom to top, or do you have to be both of them saying they're equal to each other? No. Okay. You don't need to worry about just calling it 0, 0, 1, 1, and 2, 2, and it's the same thing backwards or forwards.
So if it's in any of the sentences, it's too late. So we would we have to write that according to which is why for each we can use it for each method. It can be Transpose radius. Also creates. Two things similar to it's looking for an animal. We can have the artificial out of that. So
that doesn't change for 5 with addition, that would be like, so if 5, if someone's already at 5,
the logic is we're trying to check to see if anything else. So it made if this and if
these 2,
yeah, or and if one or if it exists at that point, it exists at this specific point, and these are the spots covered. So we can do it by rows.
All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. All right, on a scale of 1 to 10, how tired are we? Yeah, I'm seeing it. I'm feeling it. It's all right, right? This is the last thing we're gonna do. Okay. So looking at this, let's see if we can find a pattern. How would we access the first element here? 0. Okay, how would we get this one? 1, 1. How would we get this one? 2, 2. Okay, so that seems like a pretty good pattern, right? This one is what? 0, 2. Okay, so less obvious of a pattern, but there is still one. I could say that this is the length minus like I. Yeah, we'll see in a minute. Okay, don't worry. We're gonna see it. Okay, so let's do it. So the first thing I'm going to do is I'm going to create an array that's going to keep track of all my lefts. Oh, well, first of all, I just want to show the difference between hard coding and not hard coding a little bit. There's no reason we couldn't have done this, right? If this dot board at 0 is equal to this dot board at 1 is equal to this dot board right. Will this give us the answer? Yeah, right? Are we all totally capable of doing that? Yes, all right. So we still got our energy, yeah? Now, I do want to say, although this is reasonable, especially for tic-tac-toe, there's this idea of what if someday we wanted to expand on our tic-tac-toe? So instead of having a 3x3, we had a 4x4, and we'd have to change some other things. Right? For one thing, we'd have to change the way we generated our moves array and also how we generated our moves and our moves are remaining. And that's something we'll maybe go into more tomorrow near the end of the day. But if we hard code that, we also have to keep hard coding these, right? And that's going to start getting more and more complicated. So to make this a little bit more flexible, it'd be great if we didn't have to say the exact size of it. So one of the ways we can do that is I'm going to make an array that says left down. So this is going to be my array downwards. I'm going to start that as empty. I'm also going to do a let right down. And I'm going to set that to be empty. Next thing I'm going to do is do a for loop. So I'm going to say for let I equals 0, while I is less than this dot board dot length I plus plus. And in here, I'm going to shuffle each element that I hit into my array, and then I'm going to do that every again, the same way we did it in the horizontal. So for left down, I'm going to say left down dot push this dot board I at I. Right? This is to cover the 0, 0, 1, 1, 2, 2. Does that line make sense? Because I 0, 0, 1, 1, 2, 2, they stay the same, we can just push forward at I. And so we'll be able to take down that upper left to lower right combo. Okay, so doing the right one is going to be a little bit more of a brain teaser, but I think we can do it. So we'll say right down dot push, and this will be this dot board. And so here, this is a 2, right? Or this one's a 0. Well, it doesn't really matter. I can start from here down, too. So here, this is what I'm going to write here. we'll look at it in a second. We'll say this dot board, oops, dot board dot length minus I minus 1, and we'll key into it at I. So let's talk about that line, because it might not be totally intuitive. So when I is 0, we're going to be keying into our length, which is 3, minus I, which is 0, minus 1, which is 2. Brings us to this line here, and then at I is 0, so it's right here. This is our first iteration. Right? Don't forget we've already done this one, right? So we got here, I gets incremented to 1. We say this dot board dot length, which is 3, minus I, which is 1, so that brings us back down to 2, minus 1, this gives us 1. So now we're on this row, at I, which is 1, gives us our middle. Okay, we'll go to the next one. I becomes 2. This dot board dot length is 3 minus I, so 3 minus 2 is 1. Minus I again is 0, so that gives us up to here. And then at I, which is 2, gives us here. So if you walk through, we'll get that diagonal. So then the last line is not too bad, right? The last line is just if left down dot every, and we can just do our element is equal to element equal to left down at 0. If that's the case, we'll just reset our winner. So we'll say this dot winner is equal to left down at 0. And then it's essentially the exact same code here. So I'm just going to duplicate it. But everywhere that it says left down, it will say, we'll have it say right down. And again, down here we can return this dot winner. Shall we test? Okay, so we'll go down to the bottom. And we'll place our mark. Well, right now we can just say this dot is diagonal. We should get undefined, because we don't have one. Then we placed one x at 1. We'll place an x at 5, and we'll place an x at, oops, well, it's uncommon that. Place an x at 9. This should give us back an x now. Perfect. And then we'll try it again the other way. So this will be 3, 5, and 7. And we can still get our x, which we do. So we've totally got it. Done. So that's what we're going to do in our find winner. So our find winner now does this. Invoke, invoke, invoke. Okay, so now our find winner is going to update our winner. And then we can just do a little check to see if it's also a tie. So we'll say if this dot moves remaining is equal to 0, and there's no this dot winner, this dot winner equals tie. Okay, Sam. Yes. Great question. He says, do I have to put, I'm just trying to highlight the S and the I. There we go. No, just the S and the I. We need to have this in front of it. There we go. Great question. Okay. We're not going to write any more code today, but we are going to go over what we did. Okay? And we'll finish off the game tomorrow. This pretty much finishes our board class. The only thing left we have is to print the board and display it. Let's see how. So if we actually look at the transpose, we'll be looking at 159, which is the same as what it is untransposed. So it won't work. They actually stay the same. Yeah, they just switch places because it flips like on the axis. But nice catch. Okay, so let's go over what we did today. All right, it was a big day. I know it was brutal. It felt like really hard, but this is like part of just learning how to do the object-oriented programming. It's just the beginning, and your project will be a slightly smaller scope project. Okay, so the first thing we did today was talk about human player. Our human player, we imported the read line, specifically read line sync. We had our constructor. It took in a name and a symbol. It set the name to the name, the symbol to the symbol. We had a method called getMove that all it did was return the input from the user after it was asked the question of what do we return. We then exported human player so that we'll be able to require that in the game file. Okay? We also had board. Board is where we spent most of our time today. Board, we created a matrix to be our default board. This is the board we'll allow our users to see. We made it a 3x3 matrix, numbers 1 through 9. We created a moves remaining count to keep track of how many times a user's moved. We set a winner to be initialized at undefined because the game starts, there's no winner, we don't know. And we created this moves object. This gave us access to at every single position in the matrix. It told us what the row and the column will be and how we can access into our board. We then wrote an isValidMove. I'll get rid of that. Our isValidMove said, hey, if the user's move isn't in our move object, we already know it's false. No point in proceeding. Because if it's not a 1, 2, 3, 4, all the way up to 9, it's not in our object, it's going to key in, it's going to get undefined, that's not going to fly. However, if it is in the move, we get back an array, right, with the row and the column. We then set variables row and column to those elements in the array, right? This was something called object destructuring, which we learned. Kind of, we just like touched it, but not much. But we also said we could write it this way, the way we're more familiar with. We then wanted to make sure that the type of the board, the element at that index on the board of the row and the column was not a string. If it was a string, it means it's already been updated on our tic-tac-toe board. If it's a number, though, we know we're good to go. Because everything the user puts in will be coming in as a string. And since the things start as numbers, we're able to use type to differentiate whether or not it's been updated already. We then wrote placeMark. Again, we separated out the row and column from our moves object, passing in the move and pulling out that array and separating the row and column. On the next line, we keyed into our board at that row and column and reassigned the value of the element to be the symbol that was passed into the function. And on line 29, we decremented the moves remaining. If we've added a new element to the board, we would lose one move, right? We started at 9 because there's 9 places, right? So that's moving us towards the tie outcome. We then wrote the monster, right? The monster was find winner. We had this dot horizontal is a helper function. This is going to check the horizontal parts of the matrices. We had this dot vertical. This would check the vertical part of the matrices. And we had this dot diagonal, checking the diagonals of the matrices. All of these methods we used for their side effects to help update and change the value of winner. We then check, hey, if moves remaining is equal to 0 and there is no winner, then the winner is a tie. Otherwise, our winner will be appropriately set, either to undefined because the game's not over, or to the winning symbol, which we'll see in the other moves. Is horizontal. We pass in a board because we decided that we wanted to use it again for is vertical because it's easier to check all of the elements in one array than checking 3 elements or 1 element in 3 different arrays at different spots. Doing the vertical check is a lot more difficult than doing the horizontal. So we decided to write it in a way so that in our vertical we could transpose it and reuse it. That's the point of this part. We said, hey, in our board, for each row, we're going to check if every element in that row is identical to the first element in that row. Because if it is, it's safe to say that they're all the same, right? And if they're all the same, we have a winner. This updated our winner. Is vertical is the same thing, only it first transposes the matrix and creates a duplicate of what the current board state looks like. It does that by creating a matrix, an empty array. It goes through the current board. At the index of I, it assigns it to an empty array, and then it iterates through the row of the board and swaps the position so that dup I at j is equal to board at ji. From there, we can use that in our is vertical. We get our transpose, and then we just return the value from is horizontal. Finally, we wrote is diagonal. We created a left down array and a right down array. We iterated from 0 to the board's length of 3 and incremented by I. We pushed into our left board at I, because that represented 0, 0, 1, 1, 2, 2. And then we also pushed in board.length minus I minus 1, which gives us to this column and I. And this allowed us to do this diagonal. So we could do this one and this one at the same time. From there, we just did the same thing that we did in the middle of horizontal, which was, hey, is every element in this array identical? If it is, let's update the winner to be that identical element. Same again with right down. And that's it. I think that's everything we covered. Any questions on any of that and how that's working? Right, so tomorrow we can make a little print to display the board. That'll probably be the warm-up activity, to be honest. So you can go ahead and start working on that if you want, which will just be print the board. What? Print out the board so that the user can visually see the board. And then we'll begin working on the game class, which will have just a few functions that are going to allow us to keep the game rolling until the game state is over. So the bulk of the game is done. But we still need to have just those outlining rules that keep everything in check and switch players. Any other questions? All right, let's get some sleep. We'll come back fresh. All right, we got this.